In TCP/IP model, logical addresses belongs to either IPv4 family or it will be the IPv6 family. In IPv4 family, logical addresses are 32-bit long, where in IPv6 it is 128-bit long. So we can generate 2 to the power 32 different IP addresses for IPv4 or 2 to the power 128 IP addresses for IPv6. IPv4 supports classful and the classless addressing, whereas IPv6 supports only the classless addressing. We can configure a machine by using IPv4 address either statically, that is the manually, or we can use DHCP server to assign the IP addresses. Whereas in IPv6, it uses stateless auto configuration or it uses DHCP v6 to assign IP address for a machine. IPv4 supports multicast as well as the broadcast, whereas IPv6 does not support broadcasting. Main difference between the IPv4 and the IPv6 is that the protocol stack. Here you will get 5 different protocols: IPv4, ICMP, IGMP, ARP and RARP. Whereas in IPv6 you will get only 2 protocols, IPv6 and ICMP-v6. ICMP-v6 is the combination of ICMP, IGMP, ARP, where RARP has been removed from IPv6 family. In IPv4 system, we have classful addresses and the classless addresses. In the classful addresses, we can divide all the IP addresses into 5 different categories: Class A, Class B, Class C, Class D and Class E. In Class A, NAT ID is 8-bit, host ID is 24-bit. In Class B, NAT ID is 16-bit, host ID is 16-bit. In Class C, NAT ID is 24-bit, host ID is 8-bit. Here, to identify whether the address is Class A, Class B or Class C, the first bit, just by checking this bit, we can say this is Class A, Class B or Class C. In the Class A, it starts with 0. In Class B, it starts with 10. In Class C, it will be 110. In Class D, it will be 1110. Class D is used for multicasting and Class E is reserved for future use. Here, Class A addresses ranges from 0 to 127 as the NAT ID, 128 to 191 as the NAT ID, 192 to 223 as the NAT ID for the Class C address. So whenever we'll get any IP address, if I check the first higher order bits on the time, if the value lies between this range, on the time we will say this is the Class A address. Any range, so these are the ranges specified for the different categories. In the classless addresses, the total 32 bits are divided into 2 parts: network ID and the host ID. Here, if it uses n bits for the NAT ID, then 32 minus n bits for the host ID. Suppose the format is x.y.z.t/n. Suppose 192.176.45.11/16. So this notation is called the CIDR notation. Here you can see it looks 192, it ranges between the 192 to 223, so it will be the Class C address, but not, this is not the class full addresses because we are using 16-bit as the NAT ID. So it looks like that it is Class C address, but actually it is Class B type address, so that's why this is the classless addresses. In IPv6, logical address is 128 bits long. For example, this is an IPv6 address. We can suppress zeros, continuous zeros, by using double colon. So this address is similar to this. Here we can divide all the logical addresses in IPv6 family into 3 types: unicast address, multicast address and anycast address. In unicast address, this IP address will identify a single interface. Here this is an example. One machine wants to communicate with another machine, it will use unicast address. Multicast address means group of devices. Here this computer wants to send data to a group of computers. On the time it will use multicast address. It uses the prefix FF00, this format. For example, this is the example for all routers in the multicast address. Anycast address means again it is sending to a group of computers. But the difference with the multicast address and the anycast address is that the data packet will reach to the particular computer that is easily accessible. Here in this case, this is the group of computers. They are sharing the same prefixes. For example, here this is the IP addresses for server A, server B, server A, B and C. Here they have the same IP addresses. When the data packet will come, this server, to reach this server, the cost is 50, 75 and the 10. So the data packet will reach here. So unicast address identifies group of computers, but the data packet will reach to a single computer that is easily accessible.